Welcome back to My Smart Learning. This is your physics lessons for year 10. We're looking at electrical circuits. So it's GCSE physics for year 10 and 11, studying for the GCSE exams. So we're looking at series circuits. Last time we looked at various components. We looked at VI graphs for, we looked at the resistance in a wire investigation, and we also looked at the graphs for a fixed resistor or a wire. We looked at a diode, we looked at the light bulb, the filament light, and we also looked at a thermistor and an LDR. What we're focusing on today is quite a short, snappy lesson looking at series circuits. So our objective: what are series circuits and what properties do they show? Now, like I like to start all my lessons, you got your quick recall PT, your progress testing. I like to call it high five. You get them all right, you get a virtual high five from me. Now, number one, question one, length of a wire affects resistance. What happens if I increase the length of a wire? What happens to its resistance? That's question one. Question two, Ohm's law. Can you state Ohm's law? You might want to write this one down. This might take a few seconds, so you might want to press pause while you're going through these questions. Question three, V equals, based on Ohm's law, what does V equal? Question four, what is an LDR and how does its resistance change? What's an LDR? What does it stand for? And how does its resistance change? And the last question, question five, what is a thermistor and how does its resistance change? So you might want to pause the video, have a quick check of all your answers, and I'm going to go through the answers now. So question one, length of a wire, how does it affect the resistance? The longer the wire, the higher the resistance. We talked about that last time. The longer the wire, the higher the resistance. There's more atoms, there's more ions in the way. The electrons have to flow through them, and they're finding it more difficult. Ohm's law states that the current is directly proportional to the voltage applied. The current is directly proportional to the voltage applied as long as the temperature remains constant. As long as the temperature doesn't change, doesn't get too hot. Because remember, with the filament bulb, the temperature gets hotter, its current doesn't go up as much anymore, it starts to flatten off. V equals, based on Ohm's law, V equals IR, V equals IR, and if you can rearrange that equation, resistance would be voltage divided by the current. LDR, what's an LDR? It is a light-dependent resistor, and depending on the amount of light, the brighter the light, the higher the light intensity, its resistance decreases, it becomes less. So therefore its current increases. A thermistor then is a special type of resistor. Its resistance changes due to the temperature, and the hotter it gets, the higher the temperature, the lower the resistance. And again, if it's low resistance, that means there's more current flowing through it. So, what are series circuits then? A series circuit, so actually let's look at some basic ideas very quickly. So that's what a series circuit is. A series circuit is just a circuit with just one loop. There's just one loop there, there's no other branches coming off it. So one loop is known as a series circuit. And there's my series circuit. I've got a cell and I've got a bulb. And if I connect it with the switch and there's no gaps in the circuit, the bulb will obviously light up. However, if I keep adding extra cells, so that's become a battery of cells, what happens to the brightness of the bulb? Now this should be quite straightforward. It's something you would have done in primary school. More more cells, which gives you a greater voltage. You'll have a greater potential difference. Remember, the voltage, the correct word for voltage is potential difference. If I keep adding more cells, the bulb should get brighter. So it's a brighter bulb. So if a battery is added, the current will, what would happen? It would increase. So there'll be more current because there is a greater push on the electrons. You're pushing those electrons more of the energy is being transferred to the bulb because there's more batteries, there must be more energy because the energy comes from the battery. What about start for the same circuit again, my series circuit, they're both series circuits. What about if I added an extra bulb? So if I've added an extra bulb this time, but I've still got one cell, what would now happen to my brightness? Well, this energy now has to be shared between the two bulbs. So what would happen to the brightness? Well, the brightness should decrease. So it's dimmer compared to the original bulb. So if a bulb is added, the current will decrease because there is a greater resistance in the circuit. So if a bulb is added, the current will decrease because there's greater resistance in the circuit, because there's more bulbs, there's more things for the current to go through, therefore there'll be more resistance in the circuit. So that's what our series circuit is. If I keep adding cells then, so in series, a series is just when you keep adding things in a line. So it's just one loop, like the previous page there, I had one cell. If I add another cell, if I add another cell, you keep adding cells in series. So it becomes a battery of cells. Well, what happens to the voltage? Now, one typical cell, you use, I don't know, your Duracell or Eveready, there are other battery companies available. But if I keep adding them in series, if I keep adding them in a line, then if I had one cell, which is 1.5, what would happen if I added another cell? What would happen to the total potential difference or the total voltage? What about if I added another one? So this was a very simple practical you can do. Just keep adding cells together, get your voltmeter and keep connecting your voltmeter and measuring the amount of energy in the cells. Well, what you'd get, if I had one cell which is 1.5 volts, if I added another cell, they just keep adding. So it's very simple. So keep adding cells in series and you just add them up. So one cell will be 1.5. If I had two cells, 1.5 plus 1.5 will be 3. If I had three cells, it would be 1.5 plus 1.5 plus 1.5. That gives you 4.5. Now, another rule about series circuits then. We need to know what happens to the current and what happens to the voltage of the components in a series circuit. So here are two series circuits. In this series circuit, I've just got two bulbs, two filament bulbs in series. And I'm going to measure, I'm going to get an ammeter, and I'm going to stick my ammeter in this position there, and I'm going to take a reading and write down what is the current in amps there. And then I'm going to put it in between the bulbs and write down what the current is there. Take the ammeter out, then I'm going to stick it into this position there, and I'm going to write down what the current is there. So that's measuring the current. In my different practical, I'm going to measure the potential difference. I could do it for the cell there, I could do it for that bulb, and I could do it for that bulb. In this little diagram, you can see there's the potential difference there, the voltage in position 1. And then I'll move my voltmeter and I'm going to move it into position 2 across this resistor. And then I'm going to move my voltmeter and I'll move into position 3 and measure the potential difference across this resistor there. So with this particular investigation, if I set my equipment up like this, I can draw a results table. So I've got my ammeter in position 1, 2 and 3. And then I've got my voltmeter in position 1, 2 and 3. And I've got my voltage there. I've put dashes there because obviously you're not measuring the current in those positions there with the voltage. So I could have done this as two separate tables, would have made it easier. So here's some results from a practical that I did. So in this circuit, I had 2 amps, 2 amps and 2 amps. So if I go back here, I'll measure 2 amps there, I measured 2 amps there, and I measured 2 amps there. And in my voltmeter, I've got 3, 1.5, 1.5. So if I go back, I've got 3 there, I had 1.5 and 1.5. So what can I conclude from that? Well, I can conclude that the current was the same at every single point. And the voltage, I had 3 there. What would I get there and what would I get there? I had 1.5 and 1.5. Based on this diagram, if I had a 6 volt battery, what you should notice, if I had 3 there, 1.5 and 1.5, it must have been shared out equally between those two resistors because they're exactly the same. So with this particular diagram, if I was 6 there, I would have 3 there and 3 there. So the voltage is shared out, and that's why the bulbs got dimmer, whereas the current was exactly the same at every single point. So, first conclusion. In a series circuit, the current is the same at every point. So if I've got 2 amps there, what's it going to be there? Well, it's going to be 2 amps there, it's going to be 2 amps there, it's going to be 2 amps there, because the current is the same at any point. Why is that? Well, remember, current is the flow of electric charge. I equals Q over T. Because remember, Q equals IT, quit, Q equals IT. So charge equals current times time. So if I want the current, I want to divide the charge by the T, the time. So charge divided by the time, Q over T. So current is the rate of flow of charge. So it's the flow of something, it's the flow of electric charge. So electric charge is flowing through this circuit. Well, if you imagine it's like pipes from a radiator with your central heating system. If that was the boiler and there's water flowing through your pipes, well, the water doesn't get used up because the water keeps going round and round and round. Same thing for current, electric current. You don't use up electric current. It's just like water flowing through the pipes. The water doesn't disappear. It's the same water going all the way around. So if I've got 2 along this path, it's going to still be 2. So if there's 2 people walking along this path, I've still got 2 people there, I've still got 2 people there, I've still got 2 people there, I've still got 2 people there. It's only one path it can take. So that's the first conclusion. The current is the same at all points around a series circuit. Now, if I added extra bulbs to this, obviously there'll be more resistance like you saw on the previous slide where the bulbs got dimmer, which makes it so that the current could be reduced. So if that became, let's say, 1.5 amps, that'll still be 1.5 amps there, still be 1.5 amps there, and still be 1.5 amps there. And if I added another bulb, it might reduce it down to 1 amp. It'll be 1 amp there, 1 amp there, 1 amp there, 1 amp there. The rule is this though, the current, whatever it is at any point, it's going to be the same at every single point. So, what about voltage in a series circuit? So based on our previous data, we can conclude that whatever the voltage was from my cells, or my battery of cells, it's going to be shared amongst my components. And if my components are exactly the same, then the components will get the equal share of that voltage, that potential difference. So if I've got 6 volts across this particular battery there, then, and if these bulbs are identical, what would I get at each of those bulbs? Well, if I've got 6 there and there's 3 bulbs, so share them out equally. So I'll get 2 volts, 2 volts, and 2 volts. So you should get 2 volts across any of those individual bulbs. What about if I measured it across 2 bulbs together? Well, the potential difference is the energy change between here and here. So that's 2 volts and that's 2 volts. Well, I can just add those together because it will give me 4 volts. So I get 4 volts across 2 of them. And if I measured it across all 3 of them, I'd get the same as what's going across the battery. It'd be 6 volts. So the last thing for series circuits then is the resistance. The resistance then, if I've got, that's a resistor, well it's got resistance, but if that was a resistor of 100 ohms, and that was a resistor of 100 ohms, and that had a resistance of 100 ohms, what would the total resistance be? Well, it's actually really simple in a series circuit. You just add them up. So the total resistance, we say R subscript T, or R subscript total, is the first resistor plus the second resistor plus as many resistors as you want, keep going. That's the total, so you just add them up. So simple as that. So if I had 10 ohms and 10 ohms, it would be a total of 20 ohms. Well, that's it for series circuits. It's pretty simple, pretty straightforward. The 3 conclusions that we need to know is that in a series circuit, if I keep adding cells, the cells you keep, the total of the voltage of the cells, you just keep adding them up. So if you got 1.5, then it'll be plus another 1.5, plus another 1.5, and so on and so on. But what are the rules with a series circuit? The rules of the series circuits are, the first one is that the current is the same at every point. The current is the same at any point. The second rule is that the voltage is shared amongst its components. So whatever the total voltage is from the battery, it will be shared amongst its components. And the last rule is the total resistance of the components is the individual resistance of each component added together. So that's series circuits for you, for year 10s. It's a short, snappy lesson. The next lesson we're going to go on to parallel circuits, which is a little bit more complicated compared to the series circuits. However, if that's been useful and you've learned something today, please watch the videos, like the videos, subscribe to the videos, and please share them. So if you got I forgot to give you a high five. If you got all 5 questions right from the beginning and your little starter activity, your recall PT, excellent. I'm glad to hear it. A quick high five from me. Look after yourselves. I hope you're keeping well, and we'll hope to see you in school in the near future, not so distant future. But keep looking after yourselves and take care and keep watching the videos. See you next time.